Given 1 plus I to the 10th power. By using Euler identity, I'm supposed to change this into Euler form. And then after changing it to the Euler form, take the 10th power, and then write the final answer in the rectangular form. That's the question. Let's see how that's done. So first, 1 plus I. How do I change this into Euler form? Euler form is R e to the I theta, where theta should be always in radians if you write it in Euler form. Okay, so it goes like this. R is just the magnitude. So R is just the modulus of the complex number, which is square root of 1 squared plus 1 squared. Be careful never to include I in here. Okay, don't do that. The formula is you have to get rid of the I when you apply this formula, which is a square root of 2. So we know that R is square root of 2. And then for theta, which we call the argument, it's supposed to be tangent inverse of B over A. Right? B is 1, A is 1, so you have B over A. And then plus alpha. Alpha is determined by which quadrant you're on. If you're in the first or on the right side, you don't have to modify anything, but if you're on the left side, you should add pi in the third quadrant or subtract pi in the fourth. No, add pi in the second quadrant and subtract pi if you're in the third quadrant. Okay? So that's the value of I. Which quadrant is this on? 1, because they're both positive, right? So you don't have to use any other value for I. It's just 0, okay? All right, so we end up with tangent inverse of 1, because 1 over 1 is 1. What's tangent inverse of 1? 45 degrees, or in radians, it's pi over 4. So that's how you change it to Euler form. 1 plus I is radical 2 e to the pi over 4 I. That's the Euler form of the number 1 plus I. And for the purpose of taking many powers, the Euler form is easier because, I mean, imagine having to multiply 1 plus I 10 times. That's not fun. But this one's easy because now you can just take radical 2 to the 10th power times e to the pi over 4 I to the 10th power. Okay? And then because this is 2 to the 1/2 power to the 10th power, and when you have two numbers like this, you have to multiply them, right? So you end up with 10 pi over 4I, because you multiply 10 to this thing. 1/2 times 10 is 5, so you have 2 to the 5th power, and e to the 10 and 4 reduces to what over what? 5 pi over 4I, right?
Over 2.
Oh, 2, thank you. Over 2. Now, what's 5 pi over 2? Pi over 2 is 90 degrees, and you're doing this 5 times, right? So let's see where you reach if you do this 5 times. 1, 2, 3, 4, 5. So where are you at?
90.
So you see that 5 pi over 2 is coterminal to the 90 degree one. Okay? If you don't trust me, you can do this. You can do 90 times, since pi over 2 is 90 degrees, multiply this by 5, you get 450 degrees. And then to get coterminal angles, you can add 360 or subtract 360 many times, right? Here, if you subtract 360, you get exactly 90 degrees. So we know that these two angles differ by 360. So we know that this is coterminal to 90 degrees. Okay? You could do it this way, or you can just draw it and just count 1, 2, 3, 4, 5 and get to the 90 degrees. Whatever you do, I know that this one is same as 2 to the 5th is 32. And I know that this is same as e to the pi over 2I. But then we also have another question. What is 2 to the pi over 2I exactly? That's like saying its length is 1, right? And angle-wise, it's 90 degrees. What is that number if you write it in rectangular form? Remember, this is the imaginary value axis. This is the real axis. So if you go,
1I.
it's just plus 1I, right? So this is just 1I. So what you're doing is you're doing 32 times I, so that it's 32I. That's how you get this answer. by making use of the Euler form. Okay, let's do another question similar to it. So think about the following question. If you had square root of 2 angle 30 degrees to 5th power times radical 2 to e to the pi over 4i. Now, since this side is in polar form and that's in Euler form, it will be helpful if you convert either the Euler form into polar form or polar form into Euler form. Let me show you how to do it by using changing this into Euler form. Okay, and then after this, try to think about a way to do it by making both in polar form. Okay, so let's think about this. 30 degrees in radius is, this is 180 divided by 180 divided by what gives you 30?
30, 5 or 6.
5 or 6. 180 divided by 6 gives you 30, so this is pi over 6, right? And therefore, since this is the value of r and that's the value of theta, and by Euler form we mean r e to the I theta, this thing changes into square root of 2 e to the pi over 6 I. Okay, that's what this side becomes. And then you have to take the 5th power times radical 2 e to the pi over 4 I. All right, let's continue. This is radical 2 to the 5th power times e to the pi over 6 I to the 5th power, because if you exponentiate, they distribute to each one of them. And then square root of 2 is first power, so if you multiply these two together, since these two have the same base, their exponents add. So we get 5 plus 1, which is 6. And then this one you multiply, so it's e to the 5 pi over 6i times e to the pi over 4i. This is 2 to the half power to the 6th power, so that's the same as 2 to the 3rd power. And how about this one? Same base, so you have to add the exponents. If you add them, let's see, the common denominator is 12. So this will be 10 pi over 12. This will be 3 pi over 12, right? So it'll be 13 pi. Therefore, you end up with 8 times e to the 13 pi over 12 pi. Now, if the question asks you to write down the answer in Euler form, this is where you stop. Here in the example, I have the question as write your answer in polar form where the angle is in radius. So you just have to rewrite this in polar form, which is 8 with an angle of 13 pi over 12. That's how you solve this question.